share a few more examples of how we set up and solve for x values using the quadratic formula. I wanted to let you know one of the examples is going to have a discriminant that has a perfect square root. The other one is going to have a non-perfect square root. Both of the quadratic equations are going to produce two roots because their discriminant is still going to be positive. Follow along and make sure you let me know if you have any questions. Start off with 2x squared plus 5x minus 3 equal to 0. Always make sure your quadratic equation is set equal to 0. A is going to be 2, B is 5, and C is negative 3. When I set up the equation, I like to do the opposite of B, plus or minus, b squared minus 4 times a times c, all divided by 2 times a. You're going to notice that I went ahead and squared the b, which was 25, and then in the denominator of the fraction, I did 2 times a already. Now this can be a tricky part. Now that we have it all set up, how do I know if I'm supposed to add something to 25 or b squared, or if I'm supposed to subtract? So what I like to do is multiply the negative 4 times a times c first to see, do I get a positive number or a negative? Because there are two negatives here in this product, I'm going to end up getting a positive 24. So therefore, I'm going to add 24 to 25. And notice I added 25 to 24 to get the discriminant of 49. It's the number underneath that square root symbol, which we also call the radical. This is when I'm going to break apart the problem. Remember, quadratic equations can have the maximum number of solutions of 2. So we're going to use that plus minus symbol, and we're going to do negative 5 minus the square root of 49, which is 7. So that's the one on the top. And then we're going to do negative 5 plus 7, which is the square root of 49 divided by 2, and that's on the bottom. For the top solution, negative 5 minus 7 is negative 12 divided by 2 is negative 6. And then the other root, negative 5 plus 7 divided by 2, would end up being 2 divided by 2, which would give us a root of 1. Let's try another one. This equation is x squared plus 8x plus 5 equals 0. Just remember, your quadratic equations should always be set equal to 0 to use the quadratic formula. A here is 1, B is 8, and C is 5. Went ahead and set up the quadratic formula. The opposite of B plus or minus b squared minus 4 times a times c, all divided by 2 times a. You're going to notice that I did put in my b squared, which is 64, and I did 2 times a in the denominator, which would have been 2. Now, the tricky part is what happens when we do the negative 4 times 1 times 5. So just so you know, there is one negative number. Negative 4 times 1 is negative 4. Negative 4 times 5 is negative 20. So therefore, I would do 64 minus 20. When I do 64 minus 20, I end up with a discriminant of 44. Now, the square root of 44 is what we call a non-perfect square root. It's going to give us a number that's a messy decimal, something that is not going to be easily able to terminate when it comes to the decimal. You're going to notice when I broke apart the problem to see what the roots were, we know it's going to have two roots because the discriminant, even though it's a non-perfect square root of 44, it's still positive, so we're still going to have two roots. I broke it apart and didn't simplify the square root of 44 yet. I did negative 8 plus the square root of 44 divided by 2, and then in the bottom, negative 8 minus the square root of 44 divided by 2. Using a calculator, you can estimate what the square root of 44 would be. It's approximately 6.7. If you want to use a calculator, so you round at the end, what I would do is this. You're going to notice that I boxed off the numerator in both of the problems. So what I would do is negative 8 plus the square root of 44, hit enter on your calculator, and then hit divide by 2 and hit enter. You're going to get the root of negative 68 hundredths. I rounded to the nearest hundredths place. In the bottom problem, negative 8 minus the square root of 44, I would type that in, hit enter, then divide by 2 and hit enter again, and I got my second root of negative 7 and 32 hundredths. I also rounded to the nearest hundredths place. I hope these two examples helped. I do know that sometimes it's frustrating when you don't get a perfect square root. You don't know if you're correct or not. So just remember, if you have a positive number underneath the square root symbol, it's okay. You're always going to have two roots. If you have a non-perfect square root, you're going to have messier decimals. Just remember to try the product first before you start adding or subtracting, and let me know if you get stuck. Thanks.